What's up my friends, welcome back. This will be a special video because as you have seen we have just hit 50k subscribers for YouTube and that's an amazing number, and in order to thank you to all, I will answer some questions that you have posted on the community page of YouTube and also on Facebook. Before we even start, please sorry for my bad English, and also I can't answer all of the questions because there are a lot of them, so let's just start. First, I will answer the question on Patreon because there is just one or two questions on Patreon, so let me just answer that, and then we will go to Facebook and YouTube page, and also a little bit on Instagram. Okay, so on Patreon, Robert asked me, "Hi, my question regards driving inductive loads from the Arduino, for example, a 12 volts main relay. The relay is like this one," and he passed me a PDF, and it will switch up to 5 amp and 240 volts. Would it be okay to drive the relay through a 1K resistor and a transistor like the 2N2222 directly from the Arduino? Or would you recommend a photo transistor like the Mach 8101? Well, as you know, relays are just some coils that will switch as a metal connector. And yes, there will be a lot of voltage spikes in those coils, so you will want to separate the Arduino from the rest of the coils. As you know, the module, the PDF that you send me is just a PDF for the actual relay, but when you buy those on eBay you will get the entire module. So you will have the module with the relay, and then not a photo transistor but an optocoupler in order to separate the high voltage spikes that might occur with the rest of the circuit. So you might want to put an optocoupler between the Arduino and your coil. That will be great. Okay, another question from Patreon, Robert, once again. I wonder if you could tell us a bit about the alternative of the Atmega 328 and the pros and cons of different choices. I can see the good reason of the Atmega 328 when the ESP32 is much faster and has a lot of more built-in features like Wi-Fi and Bluetooth, but I haven't used it either, cheap. So anyway, I haven't used the ESP32, but the reason that most of us use the Arduino is because it is very cheap, and also there is a lot of information about how to use it. If you start using the STM32 or the ASP, well, there's not much information about that. But if you find libraries and you can adapt the codes from the Arduino for the ESP or STM, that is great, because there is a lot of information, a lot of codes that you could merge together in a bigger project with the Arduino. That's why I am using the Arduino, and I can't tell if it's an advantage or not. I've used the ESP8266, and that is not just a Wi-Fi module, it is a microcontroller, but it only has 2 digital pins, outputs and inputs, so if that is good for you, well, you could use that. Okay, so since we have a lot of questions on YouTube community, I'll answer one from Facebook, 1 or 2, and 2 for Instagram. So let's get started. Let's start first with Facebook. Okay, so this is the question. What if I made a 2-layer PCB with only 1 layer of common ground copper filled with copper and the other layer with common VCC copper? There will be any dielectric stress on components? Well, first of all, I always fill my boards with copper, but I also put ground and ground, and as you all know, that will be a capacitor, but won't be a capacitor between the layers of ground, but between the ground and the other tracks. It will be very small, but we've made some tests during this last year of university. We've made a project using the ANRF24 radio module, and we had to put the entire module on the outside of the board because the capacitance of the board was affecting the transmission and the SPA communication. So when you're using a copper filled board, you'll always have capacitance, parasitic capacitance added. Even if you don't use that layer of copper, the tracks one to each other will be like a small capacitor. So I'm not sure your question is that if putting VCC and ground will lowering the capacitance. I'm not sure, because you will still have ground on the bottom layer, so all the tracks that are not ground on the top layer will create like some sort of capacitance between them. Very small, but it will be there. Okay, so another question from Facebook. How much time did it took to mill the Arduino board? Okay, so this question is regarding the last video of the LS Mill PCB miller. And yes, to mill the entire layer, that was just a 1-layer board. It took me around 50 minutes and maybe 4 more minutes to drill all the holes. I've made the holes manually, and then 2 or 3 minutes to cut the entire outline of the board. So a total of maybe 20 minutes to make the board. You have to just sandpaper it a bit, clean it, and you can just start soldering. Soldering this kind of boards with the CNC mill, made with the CNC mill, is very difficult because solder will stick to all the copper parts, not only the pads that you want, So to answer your question, around 20 minutes and maybe creating the G-code 2 minutes more, selecting the tool diameter and all the settings as the feed rate and so on. Okay, so EEP blog asked me, when did you start to mess with electronics? Well, I started my channel like 3 or 4 years ago, but I started studying electronics 5 years ago when I joined college here in Barcelona. So that's the answer. Okay, another question. How did you get into 3D printing? Well, I bought my first 3D printer. I bought a Prusa, a fake Prusa. The G-Tech i3 Prusa was the name. Anyway, it was a fake printer. It was very expensive back then, like 2.5 years ago. And that's how I started. My first print was a cube that I haven't even finished that print because I had a lot of errors. But anyway, once you have a 3D printer, you can start printing stuff and making a lot of tests, changing the settings for your code, for your G-code. And that's how I started. Then I've downloaded Blender and I started editing my own parts and made a lot of cases for my DIY projects. I made the plane, the tank, and so on. Can you design and build your own 3D printer? Well, you can. Also on the internet there are already a lot of videos about that. I have on my to-do list that project, but I don't know if I'm gonna do it because it seems like not so electronics related. When you will build a 3D printer, the most difficult part is not the part of the electronics, but the frame of the printer. Because you'll have to buy a lot of metal bars, screws, and think where you will put the smooth rods and so on. So the most difficult part is the frame of the printer, not the electronics, because the electronics are just a board, the drivers for the step motors and the step motors with the supply. So you'll have to follow a schematic that is already online and maybe install the Marlin firmware, which is already made. It's very deep. If you want to make your own code, would be very difficult. But if you use the Marlin code, you just have to upload it and that's it. So it's not very difficult. I've made a tutorial on how to make your CNC, a very small CNC using motors from DVD writers. The video is on my channel if you want to see it. And there I show you the schematic, how to make the board, how to connect the drivers, upload the GRBL code, and then use BCNC or maybe Universal G-code sender and control the machine and start engraving or plotting something on a 2D shape. And that's it. That's all I have on my channel for now. I have on my to-do list a project with a 3D printer, but I don't know when that will come out. Any tips for beginners to study programming, especially C or C++, since I'm not too good at all this? LOL. Well, study programming. Well, you should buy a book and then just start any project. This is how I've learned programming. We had a small project, maybe just turn on an LED, learn about how to control ports, how to control timers, pin interruption, and just growing and making a bigger projects. And if you want to learn C++, the first step you will want to do maybe just buy an MSP, the 430. That is a very good microcontroller. Download the Texas Instrument Studio. I think there is a free version for students. And then just start using C or C++, start playing with the ports, just turn on an LED and then start from there. So any tip? Well, just get into a project. If you are into a project, you will find a lot of problems, and solving those problems will teach you how to use the microcontrollers. Okay guys, so now we are onto the YouTube community and there are a lot of questions. I'm not sure if I can answer all of these, but I will try. Okay, so the first question, what do you think about Great Scott? Well, I know his channel, I follow his channel, and he seems like a very smart guy, and he's a great Scott. I can't tell you more about that, because I don't know him. Hi Electronoobs, what is your profession? Do you work or you are a student? Well, I just finished Electronic Engineering University here in Barcelona, and I'm currently working as a YouTuber. As you all know, this is my work, and I'm also working in an escape room. If you don't know what an escape room is, well, it's a room when you can go with your friends, and you will be closed in that room, and you have like 60 minutes to get out. You have to resolve all the puzzles in order to get out. Our escape room is based on the submarine stories. It's based on a submarine story, so you have to solve all the puzzles, and you have to navigate from one country to another with the submarine, and there are a lot of panels. I'll try to put a video here on my left with the inside of the submarine. So I had to build the entire panels. There are 8 panels in each room, and there are 2 rooms, so a total of 16 panels, all with Arduinos, with LCDs, with keypads, with joysticks. You will have to fire torpedoes, you will have to control sounds, and so on. So I'm currently working there as well. just managing the cables, fixing stuff that got broken, and so on. So that is my job, and also I'm a YouTuber. And I would like to keep making videos, so that means your support will help me a lot. So thank you very much for those who are supporting me on Patreon, and for all of you for supporting this channel. Okay, let's go to the next. Which book I should study for learning electronics? Well, I can't recommend you any book because I myself, I don't use too much books. Anytime that I need something, I just Google it, because in that way you will find just the exact thing that you need. And even if you find something, that piece of text will be from another book. So I can't tell you any book, I can't recommend you any specific book. I will try to make a list when I will be editing this video, to put a list with all the books that we have used during these years in our university. So for digital, for basic digital, for basic components, and maybe a little bit of micro design. If we want to use an MPU 6050, how do we proceed from scratch just by using the datasheet, not using standard library? Thank you very much. Okay, so if you have seen my videos on the Arduino based drone, you will see that when I'm using the MPU 6050, which is an IMU unit, I never use the library. All you have to do is to use the I2C communication that module has. So you will have to go to the datasheet and see the direction for each register. So let's say you will want to read the acceleration register. As you will see, it is divided in two registers, so you will have to merge those two together to get the real value. So all you have to do is to start a new I2C communication, a serial communication using the slave address of that module, and then you will have to request the specific register. So you will send the directory, the direction of that register, and then you will tell how many registers you want to read, and it will deliver you those registers. And that's it. You don't need to use the library. All you have to do is to communicate with the registers that you want to read with the I2C communication. Hi noobs, what are you not making videos based on Arduino, based on basic like port manipulation? Strange. Faster ADC and a lot of more stuff. Okay, so what I'm understanding, what I'm not making simple Arduino based like port manipulation videos. Well, first of all, I can make a video only on port manipulation because that would be very easy. All you have to know is to set the register, to define the ports, inputs and outputs, and then use the register to control the pins as high or low and stuff like that. But if you watch any of my videos, I am trying to use more of the port manipulation, how to set the register to activate interruptions, how to use the vector of the interruptions and control the pins instead of digital write. I even talk about this in one of my past videos, I think it's in the PID control video, that the difference between digital write and port manipulation is huge, is like 30 times faster using the port manipulation, because the digital write is a made function for the Arduino, and that will have a bigger delay. So I'm introducing bits of how to use the ports in my codes. I can make a video only about that because that will be very short. What books and YouTube channel are you following? Well, I'm not following any book, but I am following a lot of YouTube channels, and I have two types of channels that I'm following. Those that are just electronics related, and then I follow some YouTube channels that are common knowledge. So for the electronics based, I'm following Great Scott, of course. I'm following Electroboom, Dave from the EEE blog. I'm following Marco Raps. I'm following Jupe Brooking, I think is the name. Also, I'm following Ludic Science and a bunch of more channels. Maybe I put the names here on when I'm editing the video because I can't remember all of those. And I'm following a lot of smaller channels as well because they are just great. And then for common knowledge channels, I recommend you to follow like Visas, Real Engineering, and also maybe It's Okay to Be Smart, because with that you will learn a lot of basic knowledge about the entire world. What is the advantage of learning microcontrollers like AVR, PIC, ARM over Arduino? Okay, so first of all, in my opinion, the Arduino is not a microcontroller, it's a board that uses the Atmega 328 chip, and it is AVR. It's a family of microcontrollers, and the Atmega 328 is made by Atmel, and the AVR is the same family from the Atmel as well. So it depends on the microcontroller that you will use. There are not advantages. If you need a microcontroller with a lot of pins, just use the Arduino Mega. So if you need more speed, just use one that uses higher speed clock, and that's it. They all use the same communication, and that's it. The advantage is depending on the microcontroller that you are using. How did you start your YouTube channel? What kept you going to this amount of followers? Are you making a living with making videos, or you have a job next to it? Well, I already talked about my job. And yes, I am making a video, I am making a living with the YouTube's videos. I would like to make this my permanent job because I enjoy making videos, and I think you like this kind of videos. My YouTube channel started like 3 or 4 years ago. First, I started like an Instagram account where I was posting all my projects. It was my first year of university, so I was posting all the projects that I was making. So I got to like 2,000 or maybe 3,000 followers. So then I started a YouTube channel, and a few days later I started the Electronoobs webpage, and I have to make all the tutorials there and then pass those tutorials to a video and so on. So that's like 2 or 3 years ago. How can I use an IC to control 4 7-segment, I think it's 7-segment displays, with remote control and use a relay to hook it up to 220 volts? Please help me. Okay, so first of all, maybe you will want to make your own 7-segment displays, because I never heard of a display that works with 220 volts. Usually 7-segment displays are using LEDs, maybe 5 or 12 volts, but maybe you want to use light bulbs of 224 volts and make a huge 7-segment display. So I know a chip, I think it's the Max 7819 or something like that, that I've used in the past tutorial to make the LED matrix, and that we can control up to 8x8 matrix. So you could use that same chip to control 4 7-segment displays and maybe apply the signal from that chip to an optocoupler, and from that optocoupler to a relay. But that will be like a lot of light bulbs, so that will be a huge project. I can't really understand your question, but use that chip. I'll try to put the name here on the screen with the name of the chip and how to use it. Will you make a Bluetooth gamepad with the ESP32? Well, no, but I will put this kind of projects on my to-do list. What tips would you share with yourself if you could go back in time? Well, tips, I don't know, maybe I will share the numbers for the lottery. Simulation or breadboard? Well, this is a very simple question, but I like it because I always like to talk about how to get a project done. So if you have an idea, you first need an idea, and then you will have to simulate that, because the SPICE programs, I use LT SPICE, will give you a lot of information about the current that passes, about the information of the transistors, the components, the resistors, capacitance and stuff like that. And you first have to make sure that the simulation will work. Then you pass on the breadboard. So there are a few steps that you want to go when creating a PCB. So it's simulation, test on the breadboard. Once the breadboard works, you will make the final schematic, pass that on the PCB, create the PCB, place the components, make the tracks, make sure that the design rule check is okay, and then you will send that to a professional manufacturer, or maybe just CNC mill the board. So yes, first simulation, in my case it's first simulation, and then you will make the PCB, the breadboard tests. From where you bought all of your electronics components? Well, I always use eBay to buy my components, and if not, if I can't find those on eBay, I have a local Radio Shack and I buy those here. What is the progress on the brushed drone project? Waiting for the next video. Well, right now that project is on pause because I am waiting for the components to arrive, but I am in my 5th version of the PCB, so I removed the plastic frame so the drone will weigh way less. So now I'll try to put a video with the final PCB. The PCB now has the shape of a drone, so all you have to do is to glue in place the motors, solder the transistor for the motors, the microcontroller and the radio communication, and that's it. Place the battery and upload the code. Right now I'm working on the code because I have a lot of errors, because the PID control for this kind of very small drones, it is very difficult because the momentum of the movement is very fast, so it's very difficult to control, especially when using the Mega chip. I might pass this project to an STM32 because a lot of you guys recommend me that. So right now it is on pause. Maybe I will finish it like 1 month or 2 months from now. So stay tuned for that. Do you sell any electronic related objects or DIY projects? Well, no, I'm not selling anything, but I am thinking of making a Kickstarter on the same project of the drone. Once that project will be okay, so I'll make like a kit. So I'm thinking of making maybe a kit where you will receive the transmitter board, the receiver. So you will have to go to my videos and learn how to solder the components, why we need those components, how to program the Arduinos, the flight controller, and you will end up with a working drone. So that is my idea. So it's like a kit for you to learn electronics, and at the same time you will end up with a small drone. How do you find new projects ideas? You make such a cool project. You make such cool projects. Okay, so how do I find my ideas? Well, I don't know. During the day, if I imagine something, I take out my cell phone and I write. I have an Excel, and I write all the ideas. I give a number to that idea, and then just search the components and see if I can make that idea, and if I can do it, I put it on the top of my to-do list and just start the project. How a fluorescent cathode ray television work by send the data at an accurate thing. Okay, so I think that you're asking me how a cathode tube television works. I'm not an expert, so correct me if I'm wrong. All I know is that you create some electrons here in this side, so you fire those through the tube, and then you have two parallel plates, one for the vertical axis and one for the horizontal axis, and creating the voltage amount of those plates, you change the magnetic field, and then you will change the electron direction, so it will hit one pixel or the other. So you fire the electron, change its direction, and you will hit one or another pixel, and do that very fast, so you'll see the entire picture. And the screen is coated with a material that is fluorescent, so when you hit that with an electron, it will glow, so that will be a pixel. I'm not sure, correct me if I'm wrong. From Ricardo, how to put Arduino code to a non-Arduino micro, like the Atmega 8 or the 8535 or others. So as I said before, Arduino is a board that uses the Atmega chip, in this case the Atmega 328. So you will need some kind of connection between your PC and your microcontroller. In this case, it uses an FTA programmer, which uses a word communication to pass from USB to RX and TX data. So you'll need a compiler, and you will have to make sure that your microcontroller has a bootloader in order to be able to upload codes. So all you have to do is to make sure that you can do that and make a connection between the FTDI, or if you want, you can use a CAN or JTAG communication and upload your codes. I'm not sure, I'm not an expert with this kind of stuff, but that is what you need to do. Make sure that you can program it, that is compatible with the Arduino IDE, and then install the libraries if needed, and place an IC for the communication like word communication, CAN or JTAG, or any other communication that your microcontroller has. What is your most used and favorite microcontroller? Well, this is pretty straightforward. Arduino, the Atmega 328, I use it in all my projects, and I started with that, and since I know a lot of that about that microcontroller, I use it a lot, so that is my favorite. I want to learn schematic design and PCB design. Please guide me, how can I practice? What process material book do you follow? Well, once again, I don't know too many books about that, but I do have a tutorial on how to make a board start to finish in Design Spark. So in order to make a board, first you will have to start with a software, a CAD software. I recommend you Design Spark, Eagle, or EasyEDE, which is an online platform. You will need a schematic. If you make your own schematic, make sure that that will work. Once again, simulation, PC and breadboard test, and then you make the schematic. But if you use a schematic that is already online, make the schematic make sure that you have no errors, that are not backward diodes, backward transistor, or short circuits, and then you pass to PCB. You have to have in mind that the microcontrollers usually are in the middle of the board because they have a lot of pins, power components, and all the connectors on the outline. Then the tracks, you will have to make sure that you don't have too many 90 degrees angles and stuff like that. Follow the design rule checks, make sure that you follow those rule checks, create the PCB and send it to a professional manufacturer. Follow that video if you want to learn more. In that video I show you how to make the PCB and also how to make the layout for the components in case you don't have a component. So you take the datasheet of the component, see the measurements, and then create your component and put it on your layout of the PCB. How can I get parts on the cheap? Well, if you want cheap parts, what I do here in Spain, you will find a lot of second-hand stores, so you can buy a lot of old electronics that don't work anymore, or work but they are very old, and you can get out the components if you want, or reuse that components. As my power supply, a lot of big capacitors, I found those in a lot of old electronics, so that is very cheap. Also, I use eBay because sometimes with 99 cents you can buy like 100 pieces of resistors or capacitors. Which entry-level oscilloscope could you recommend to a beginner under $600? Well, I think any oscilloscope under $600 could be very good because $600 is a lot. I now use this Keysight, which I think is a little bit over $600, but I started with a Handtech. So if you have an oscilloscope, a digital oscilloscope with 2 channels and maybe like 100 megahertz, that should be fine for a beginner to test with. If you have a integrated generator, function generator, and also a logic analyzer, that will be great, because if you are a beginner you will definitely use microcontrollers, and a logic analyzer would be great because you can connect that to your to your microcontroller and work with I2C communication, with SPI and stuff like that. So I don't know, maybe a Handtech oscilloscope, a Keysight, they are also good. It will be better if you make a video about resistors, input capture method, handlers, and how can write program using resistors. How can you write a program using resistors? Anyway, I don't understand your question. Maybe it's something I don't know. Okay, how often do you switch to another project while messing up with one? Well, that happens a lot. As you all know, I publish a video each week, and those videos are not made this week but 2 or 3 weeks before the release, because in that way I make sure that I can finish that project, because there are two types of projects that I can make. Projects that I already know that work because I make them in the past. So all I have to do is to gather the components, create the PCB, show you how they work, record, edit, and publish the video. There are also projects that I know that could work, but I never make those. So I had to make a lot of tests. So I start by the start of the week, I'm making tests, maybe 2 or 3 days of testing. If I figure that I can make that video, I will leave it aside and start another video. And during that month, I make more tests, gather more information, and when I'm sure that I can make that project, I start it over again. Okay, another question, your educational qualification, your current job, and your team members. Well, I've already talked about the first two, and team members I don't have. All the job is done by myself, so no team members for now, maybe in the future. Are you planning to make a Tesla coil? If yes, can you make a video about it? Well, yes, Tesla coil is on my to-do list, but there are already a lot of Tesla coils videos on YouTube, so I have to make it a little bit interesting. Maybe I will divide the tutorial in a few, maybe 1 or 3 videos, how to make the generator, how to wind the coil, and finally combine everything together, but I'm not sure when I will publish that video, so stay tuned for that. Okay, so there are a lot of questions that are not really questions, are requests for me to make a video. Just have this in mind, all the projects that you recommend me, I will put those on my to-do list, but I'm not sure when I will release those videos. So just stick around, enjoy this channel till you will see that video. I always announce on Instagram when I'm working on a new project. Sir, about your tutorial video on PID temperature controller DIY, I want to ask you if the circuit only applies to 12 volts DC. Well, it applies to DC, not only 12 volts. It applies to DC. You can't use AC with that, because for that you will have to use a triac. I want to use it on my project too, where I have to use a high AC voltage, probably 220 volts. Okay, so this is perfect. I am working on a project for PID temperature control, but for AC voltages. You have seen that I have a video on how to use the track and control AC voltages, and also how to control a PID control for temperature. So you merging those together, you can get the same project. So all you have to do is to detect the firing point of the AC voltage, and then the PWM signal from the PID controller project will apply on the amount of on the delay of the firing time, in order to control the power that will go to the heating element in your case. So all you have to do is to combine those two codes together. So stay tuned, I will make a video about that in maybe 2 or 3 weeks, so stay tuned for that. You made a video regarding a DIY buck converter. The efficiency was okay. Did you find any way to increase it? I need help with the buck installer MPPT charge controller, need help. Okay, so I haven't looked over that video anymore, over that project, but there is a way to increase the efficiency of a buck converter, and that is by using 2 transistors instead of just 1. You know that the buck converter uses a transistor and a diode, so when the transistor is on, the diode will be off. So instead of using that diode, just use another transistor. So you will have to switch, double switch. When you switch one to on, the other one will be off. So you will have a double duty cycle, and that will increase your efficiency, because you can control precisely when you will turn on and off each component. That's all I can say about that. You have on my webpage all the formulas in order to get the efficiency and also the output voltage. How to use PWM signal on your first ESC, the ESC without sensor. Oh, okay, so this question is regarding, this question asks me how to add the PWM control to the ESC, the old one made with no sensor. So all you have to do is to copy the code part from the new ESC project with the sensor, and all you have to do is to create an interruption on one pin, let's say digital pin 10, and with that interruption, when you enter the first time the interruption, you will start a timer, and when you enter once again, you stop the timer, and that will give you the width of the pulse, and that pulse will be the width of the PWM signal from the receiver, the radio receiver. And instead of using the potentiometer to change the speed of the commutation, the speed of switching the phases of the ESC, just use that width, multiply by the number that you want, and then apply that delay in order to control the speed. So you will read the width of the pulse, and with that width, you just control the speed. That's easy. Just copy that part from the ESC with the sensor to the ESC without sensor. But it is censored, but it uses back EMF, so it's not censored with Hall sensors. Can you make a transistor tester in the future? Well, this project, it is on my to-do list. As you have seen, I have a few videos where I show you how to make current tester, current meter, capacitance, inductance, and resistance meter. But now I'm working on the transistor tester, but it's very difficult to find that. There is a project, I will publish that link below, where you have the PCB and the code for transistor testers that is already online. You can buy it on eBay. But I would like to make my own, but that is a little bit difficult because you have to test all the pins of the transistors, so stay tuned for that. Okay guys, so that's it for today. Sorry for the question that I haven't answered yet. I will try to answer those by writing a comment on the YouTube community. Also, there were a lot of questions that weren't questioned, was just requests, so for those, have in mind that your request will be on my to-do list. Thank you very much. I hope that you enjoyed this video. Sorry for my bad English. This is an unscripted Q&A video, so if you still have any questions, just post it in the comment section below. Make sure you visit my webpage, also my Facebook page, my Instagram account. Make sure you are subscribed to this channel if you want to see more videos, and stay tuned for future projects. And for those who would like to support my work, I have a Patreon campaign, and all the links are below in the description of this video. Thank you very much. Until next video, keep up you guys.